Welcome back for the lovely log equation of doom, because getting to say of doom is fun. All right, so I put these side by side on the worksheet deliberately. So I want you to look at the left one versus the right one. There's a very subtle difference, and no, it's not that the logs have different bases. Yes, that is a difference, but that is not what I'm talking about. So I have the natural log of x plus the natural log of x minus 4 equals the natural log of 3x minus 10. And over here, log base 3 of n minus 5 plus log base 3 of n plus 3 equals 2. We had a log over there, logs everywhere. Here, not logs everywhere. That is what throws people for a loop with this second equation. With the first one, I just condense the logs on both sides, the natural logs, and then I use an e exponential and e caret, and they cancel out, and then I just have an ugly quadratic to solve. This one, we are still going to have a quadratic to solve. It's just going to be interesting. Because if you make the mistake, then you don't end up, like, there's a couple ways to make the mistake here. So in order to apply an exponential, I need it to not, technically I could apply it to a sum, but it's a little weird. So we'd prefer to condense the logs first. So I have log of A plus log of B. That addition becomes a single log, still log base 3. And I'm going to put brackets just to kind of emphasize the difference. So that is n minus 5 times n plus 3. And then the brackets are just to say that all of that, the log is applying to all of that. If you don't have the brackets, it can technically look confusing, but most people would still assume this is what you meant. And then that is all still equal to 2. Now, to undo log base 3. This is the step where a lot of books would say, and then you transform it into exponential form. And they're like, and you move this here and that there, and woo, and everything moves, and it gets hellacious if you're dyslexic. So I prefer to think of it as, I have a log base 3 here that I want to get rid of so I can get to my variables. To undo a log base 3, the opposite of that is the exponential 3. So that is what I'm going to want to apply here. 3 caret is what would cancel log base 3. But if I do it on one side, I have to do it on the other. So this becomes 3 to the second, which we know. That is 9. Now, if you put a 6 here, it's going to mess things up. Got to be a 9. If you canceled the log base 3s and still put the 9 on the other side, but you left it as a plus instead of a times, you're going to get the wrong answer. At least that one will look decently pretty, but still off. So just a FYI for the number of ways this can mess up. And because of that, I don't really like this problem, and yet I still put it on my tests all the time. Why would I do that? You small number of people who actually watch my videos. So 3 squared is 9. So now I've got to FOIL or box these together. So just in case some of y'all didn't ever watch the boxing videos, just going to run through it over here. So that is a really bad n times n squared, n times 3 is 3n, negative 5 times n is negative 5n, and then we get negative 15, just doing our multiplication. So I have n squared, 3n minus 5n is negative 2n, and a minus 15 still equal to 9. In order to solve this quadratic, I got to move the 9 over. It's got to be equal to 0 to try to factor. And odds are on these, especially with logs, it's gonna factor. We don't want you to have to check with ugly numbers. So negative 15 minus 9 is negative 24. And is equal to 0 now. So this bad boy factors. I need factors of 24 that are only 2 apart. So that is not 12 and 2, which is what my brain said at first. I'm like, no, that has 2. It doesn't subtract to 2. 6 and 4. All right, so it's going to be n with a 6, n with a 4. 1 is positive and 1 is negative. To multiply to negative 24, I'm going to make the bigger one negative, so it adds to a negative 2. So n minus 6 times n plus 4. Set that equal to 0, add the 6, so n is positive 6, and or n is negative 4. Now we have to check these. If the negative only fails in one of the logs, that is still enough to throw it out of the equation. The other catch, you have to check it in the original equation. So even the one I wrote in blue here where I compressed the logs together, that is not the original. It is whether those numbers fail in the original, what I typed. So if I put 6 in there, that's going to be log base 3 of 6 minus 5. That would be log base 3 of 1. That's okay. Plus log base 3 of 6 plus 3. That would be 9. Also okay, something I can crunch. And that does in fact equal 2. The first one actually crunches to 0. The second one is log base 3 of 9, which is 3 squared. So we would just get a 2. All right, so n equals 6 is one of our answers and would go in our fancy curly braces. Now we just got to check the negative 4. So use a different color. So we would have log base 3 of negative 4 minus 5. So log base 3 of negative 9. And if you tried to type that in the calculator using the change of base formula, calculator would say error not in domain. Sometimes it just says error divide by 0 for all of them, but I think this is one of the few times where it gives you the other error message. So that is enough to say nope. Now it turns out it's also negative in the other, but once we get one of them, just check it out. So that means up here, 6 is the only solution. So this is kind of like the whole shebang, the ugliest it gets with just straight log equations. Now this is discounting application questions, which I will still probably record a short video with those, but y'all do not have to write both. I am not going to post a quiz on this stuff because you've got videos in both classes and it's the end of the damn semester. So if I do post a quiz, it's going to be more like that super important quiz that I hope none of you missed. All right. And as always, if you have questions, come visit me. My office hours are very lonely. No one comes, except for like 1 or 2 people. Okay, bye.